Hi, everyone. Excited to get started. Hopefully you can hear me. We'll see if that's going to be in a bit. All right. Well, as we get started, please do put your location in the chat and what brings you here. Are you interested in LangChain? Have you used LangChain before? Are you new to LLMs, or are you pretty experienced with LLMs, maybe even in production? Just going to give maybe 30 more seconds or so, and then we will get started. And we'll try not to hear myself. All right, we see someone in sunny Florida, which is nice. I wish I was in Florida. Okay, well, we'll get started, and hopefully folks will join in on the chat as we kind of start a conversation about monitoring LLMs in production, and then particularly using two open source tools or tool sets at this point. It's kind of a wide ecosystem. So LangChain and the related framework and tools, and WhyLabs and the related framework and tools, including LangKit. Okay. So the first thing to note maybe on this slide is that there are a couple of links here. So we'll need to do so in our demo, but there is a WhyLabs platform sign up. So it's completely free to sign up. We'll use it in our demo, but if you want to go ahead and get that started now, go ahead. There's a link to our Slack group. And then for today's workshop, there's the slides that I'll be going through now, and then the Colab notebook, the code that we'll be going through for our demo. Okay, so introductions. So I'll start with myself. So I am a senior data scientist at WhyLabs, and I do all sorts of things related to machine learning, kind of thinking about what metrics and what do we need to measure when we're working with monitoring and understanding different models in production. As far as kind of monitoring algorithms, as well as some of our open source tools, such as WhyLogs and LangKit. I also do research in this space, and I think it's really fun to kind of see both sides of things. At the University of Washington here in Seattle. And that's stuff I do for fun on the side. So further into my role at WhyLabs, the WhyLogs side of things looks sort of like this. We will have a production environment, and there's many, many different ways that you can get data. So we think about data science and machine learning and AI in a fairly data-centric way. So we're often thinking about, well, what are the types and forms of data that comes out of this process, that goes into and comes out of this process? And you can see it in many different forms. So it might be batch data, it might be streaming data, it might be online, it might be in a feature store, lots of different formats. That's in the blue boxes on the left. And WhyLogs is a tool to kind of package that data or metadata about that data into a small package that we can use as telemetry and store and save and analyze over time to give us observability about our machine learning and AI models. So WhyLogs is our open source tool to do that. And it doesn't store your actual data at all if you don't want it to. What it does store is a bunch of distributional information so you can understand what's happening in your model, find outliers, that sort of thing. That can be passed on to WhyLabs platform, and I highly suggest that you do, because that's where we can now think about these profiles not just one at a time or a couple at a time, but in mass. And so looking at this, for all of our systems across all of our days or hours or 5-minute buckets, and start to debug what's actually happening, what's actually changing. Are we having some sort of drift? Are we seeing some sort of anomalies compared to what we see in the past? How do we compare this model that we have in production to this other model that we have in production, or to our training data? And being able to visualize it and create a number of team workflows to get alerted and react to these changes. Okay, so these are the two parts that I work on mostly as a data scientist. So WhyLabs, that the kind of intense statistics to be able to take all of that data and pull out the important metrics and pull and compress it in a way that is really helpful, as well as the monitoring side of things. So the anomaly detection, finding trends in your data once you've uploaded it. Okay, so that's where we started. And then the next thing that we came out with is a lot more directly related to LLMs, and that is LangKit. So LangKit, well, for those who are maybe not familiar with LLMs, or just a quick reminder, LLMs can look different ways. LLM stands for large language model, which is actually a term that's been around for quite a while before the current day. But now what we typically mean for large language model is a generative AI model that takes in some input as text often. So often something like what we see on the left is prompts, and outputs some response. Most often that is also text, but that could look like an image. It could look like lots of things. We're going to mostly focus on the case where the output is text here. And that's typically what people are talking about when they say LLM. So the question is once you use these models, how do we think about monitoring them? How do we understand what's happening with these systems? We'll talk about some interesting differences in this world, but we think about a number of things, and we've created the WhyLabs Language Toolkit, or LangKit for short, to dive into some of the most important questions when you have one of these LLMs or an application around an LLM in production. And that's the quality of the text, the sentiment, security, so maybe toxic information, things like this, and governance, understanding where this data came from. Okay, here are some of the questions that you might ask if you have one of these systems in production. Certainly these things come up when I'm working on these systems. So, so for a particular day's traffic, you might say, how were the prompts and responses written to the application? Maybe there's been longer responses or longer prompts over time, right? So longer prompts might signify that users of your application have changed the way that they interact with your system. Longer responses or differences in responses may say something about a change in the underlying LLM that you're using, as well as many other things. Are your prompts and responses readable and accurate to their designated intent? So, right, not just the length of responses, but we actually want some sense of how readable is it? What is, is this using really complex language? Is this using really simple language? Is it very stern and direct or kind? Certainly depends on the application, what you want there. And I won't go through all of these, but I think a couple of interesting ones that you might be surprised matter so much. One is understanding sentiment in your text, both in and out. This, depending on application, might not be directly important to you, but what we find is that seeing these differences in sentiment is another important signal in changes in either your overall system or the users of your system. And then certainly a big thing that comes up, one that we have many separate workshops on, and just will be a sliver of today, is security. So one case of security issues may be something like a jailbreak. So if you've used an LLM, which hopefully you have, but we'll get to use one today, what you may do is you may ask a question and get a response that looks something like, sorry, I can't give a response to this, or sorry, I can't do that. And this is called a refusal from the LLM. But then users may be clever and try to get some response that isn't a refusal, right? So even if it's something like using toxic language, or the example I often use is asking how to hotwire a car. The LLMs, many of the LLMs on the market, not all, will say, no, I'm not going to give a response to this, or to medical questions, I'm not going to give a response. But you may be able to change the way that you've asked to get a response. And this is really important, even as someone who builds an application around that LLM, because you want to understand how your users are using the system. You're going to be wanting to track where the application has broken down the path. And sometimes that break actually happens because the response from the LLM, even though it's plain text, it's actually one of these refusals. So finding out what percentage of people are attempting to break this, what percentage of times are these refusals found, those sorts of things are super important, as well as finding kind of sensitive information. Maybe people put in their phone numbers or social security numbers, and you want to track that before you even send it to the LLM. Because imagine if you're calling an LLM that you have no control over. So maybe it's a proprietary one like OpenAI. You're being responsible. You would be responsible for taking that customer information and passing it directly on to another company. And you really want to prevent that. And so how might you do that? You might use tools like LangKit to find these sorts of sensitive information. And then I'll skip over to governance. So questions about the policies that I have and the path through which these kind of decisions are being made. Okay, so I'd love to hear a little bit about you in the chat. So in YouTube or LinkedIn, wherever you are, share with the group kind of your name if you want to share, your company and role. I think this is important to understand. Some of us are going to be data scientists like myself and maybe a little more oriented toward the statistics side. Some of us are going to be machine learning engineers or engineers more broadly. And some of us are going to be, on the business side or many other roles. Maybe you're job hunting now. But it's really nice to get a sense of the group that we have and where people are coming from. And along with that, if you could share if you have any models deployed in production. So in addition to playing with LLMs, have you built some application around a model or deployed an LLM yourself, which is a lot of work. And how does that go? How do you find out issues about that system, right? This is the large challenge that we're always trying to solve. All right. I see some aspiring data scientists. Nice. All right, I'm gonna, please do keep filling that out, but I'm gonna keep going here. And just do a little bit of introduction to LLMs and generative AI before we jump into the open source side of things with LangChain and LangKit. Okay, so luckily this gets easier and easier every time. I'm sure many of you have heard of LLMs, talk about many generative AI systems like Stable Diffusion in the past. It's crazy that February 13th, 2023 was such a different world. I don't think we even talk as much about Stable Diffusion today because many of the language models have jumped up so much. But I think it's worth mentioning because often, even though we have this conversation about LLMs or about text specifically, there's a strong relationship between kind of language and what we often mean when we're talking about many issues and tracking and stuff like this, and that is generative AI more broadly. So generative AI doesn't have to be text like we see on the left of this graph, although that's what we're going to focus on today, frankly, and what lots of people focus on today. But this all extrapolates out to things like code generation, right? And image generation, speech generation, video, 3D models and scenes, and other applications. So lots of the issues that we run into are general to these generative kind of approaches. And we'll talk a little bit about what makes them hard, but then we'll talk a little bit about text-specific issues as well. Again, we've already gone over this. We're going to focus on LLMs, which often mean text prompts as inputs and often text as output, although an LLM technically could have many different types of outputs. So I want to give one example of a complex task and a complex goal that we have, and why this might look so different. So for anyone in chat, feel free to share what task you think this picture is trying to represent. I'll describe the task and then we'll give it a name in a little bit. But in this task, what we're doing is we're going to pass in some text. This is a couple of paragraphs of text here. And what I'd like to know is some label for some phrases within that text so that I can understand, is it a person, is it an organization or a date, or what sort of entity is this? So this might be one clue into the name of this, which is entity recognition. So what makes entity recognition so hard? Well, one is that it's not simply kind of classification of each of the different words in this phrase, although it looks very similar, it looks very close. This is actually this sort of phrase finding task, right? So we're looking at multiple, we're combining them together, and we're coming up with some entity or choosing an entity from a list that we have for this. But the funny thing is, like, this isn't even to the challenge of generative AI often. So often for generative AI, we have an even harder task, which is not only just going through and labeling some, flexible sets of data, but it's generating that data. So here's a maybe true example of generative AI. We have a request here to ChatGPT to summarize this article, and they pass a URL, and then ChatGPT provides a response. So this paragraph describing this article. So one thing that this shows is, like, this is quite difficult, right? There's not a lot of information here. And your system may or may not be able to go look up this URL and take the text from that URL and come up with this. But so the reason that I highlight this and show why it's so complex is that this is a hallucination. So in fact, this URL that it points to does not exist, or at least didn't at the time of this search. This is a completely just made up URL. And the LLM gives a response anyway, even though there's nothing at that web page, because that page doesn't exist. So why does that happen? How do we detect things like this? Like, this is a huge challenge that will be really difficult to detect. And something that I can't promise that we do perfectly, but as we collect more and more metrics, we'll start to get hints at whether or not these issues are feeding into our system more or less over time. Okay, I'm just gonna pause and check for questions. I see some introductions, awesome. Okay, so that's my brief overview of kind of LLMs, generative AI. I have many more slides. If folks want to talk about kind of definitions and the basics of those, I'm happy to share that content out. But I want to move on to, well, what do we do when we are building on top of LLMs and we have to support a system in production with these LLMs? And I want to talk about three concepts. One is evaluation, one is monitoring, and the third is observability. Okay, so evaluation. If you've done data science work, you've probably seen this term the most. And I would summarize evaluation as understanding the quality of your model. So here's a couple of examples here of where we may be going through some evaluation of two different models. So on the left, you see a model that creates kind of a straight line to distinguish between these two types of data. And on the right, we see a much more high dimensional line to distinguish between these two types of data. And evaluation is really difficult for lots of reasons. You often want to have something like testing data, so you need labels so that you can look at the percentage of instances where we've gotten things correct or things that we've gotten incorrectly. But those labels aren't 100% accurate. So then we need to think about evaluation more broadly than that. And then further than that, we may, it's not always the best thing to have perfect accuracy, especially in a world where we worry about overfitting. So we need to think about how representative our data for the test is to what we're going to see in the real world. So as a data scientist, maybe on the more academic side, although we have to think about this issue too, in that part of my life, I might, just think of the test data as something very similar to the training data. And I don't have to worry about production where you have, this much more complexity and much more realism about how this system will be used and how that will change over time and how that'll affect our system and how well we can evaluate it, how well it works. And then more importantly, in production settings, and actually many academic settings as well, we may not even have training data or labels, or sorry, we may have training data, but we may not have more testing data, more realistic testing data or labels, which means that evaluation takes a completely different path, and we have to think quite creatively about how to evaluate. Maybe we use different KPIs that relate to our system. Maybe we move to the world, often we move to the world of change. We're not quite thinking, what's the percentage accuracy? We're thinking, how do the characteristics of the data that I saw yesterday differ from the data that I saw today? Is that a consistent trend or is it not? That sort of thing. And that brings us to monitoring. So monitoring is something that you'll see much more often in production. So on the left side here, we see experimental machine learning, train and test, the sort of kind of static amount of time. We just collect data and we kind of focus in this world of just this data set that we have and however we split it. But in production machine learning, we're collecting data over time. We'll see new data tomorrow and the day after that, and so on and so forth. And we can use that time dimension to understand our system and to not quite evaluate in the same metrics that we're used to do, but get toward evaluation. So it takes a completely different skill set. And something I've talked about in the past, but this transition between kind of the experimental machine learning and the production machine learning way of looking at things and learning how to monitor your system is kind of that big jump between the two. And then the third example we have here, which I'm going to go in a little more detail about, is observability. So not only do we want to monitor that things may have changed in our system, which tells us something, but it doesn't give us any hints about what to do about that. Maybe you might decide to retrain your model or something like this. But what we would love is observability. So something that helps to pinpoint issues within our system, because not only are we looking at the overall system, inputs and outputs, we want to look at different points in time across the system. So you think of machine learning as a pipeline. So we have lots of different steps in the process. So we start with collecting data, input data, and we translate those into features. Depends on if it's kind of deep learning style of things where that happens inside of the model, or classical machine learning where that happens outside of this. But often in production cases, there's a little bit of both. Even if you're largely doing deep learning, there's normally some sort of storage of your data. Maybe you have information about the users that are using your system, and that gets feature transformed, at least somewhat. Or data cleaning would be a similar thing. So we want to collect some data kind of through multiple parts of that beginning feature side of things, but then we also collect data in the model itself. So you might have a system where at a certain layer, we want to output statistics about the data as it comes in, or different checkpoints within your model itself. Or if you have an ensemble of models, multiple models that you then bring all of the information together and come up with an average kind of output, then we definitely want to keep, the outputs of all of those different pieces. Yes. And then we move on to predictions. So we certainly want to store the predictions that the model made, just like the inputs, we need the outputs as well. And then honestly, with a lot of time in between often, we may get some hints at the ground truth or the true label for these sorts of things. So it certainly depends on the application. Applications, some that I have worked on, like related to inventory and demand, these things are actually a little bit easier because we can actually see how many items were bought the next day. And then that gives us some ground truth. Another example that I like to give is like ride sharing. If you have a model that predicts how long it might take to get your Uber from this point of the city and this point of the city, you will get ground truth after that time has elapsed and if you've collected that in the system. That differs from other applications where ground truth is much, much more rare, where you may not see any data about what eventually happened, whether or not my predictions are correct. And in that case, you certainly will lean on KPIs, so different metrics related to the business, maybe not directly related to your model, but you suspect is somewhat correlated. So for example, whether like customer feedback, whether or not they came back to your site, how many minutes did they spend on your website, that sort of thing. Okay. And so these are some examples. Again, we're kind of moving from the harder statistics from data that we have in hand to things that we've kind of created. So things like performance metrics and data quality, where we have to do some sort of measuring to get that and may need some ground truth for that, to business KPIs and things which take effort on their own, but are a little less related directly to the model. Okay, I'm gonna pause there just a second to see if there's some questions that I can clear up, and then we'll go on to LangChain plus WhyLabs. So I see one question, maybe or may not be toward me, about building courses on building LLMs from scratch. There are some really great courses on that. Not any that we give at WhyLabs. I think largely LLMs, certainly learning how an LLM works and building an LLM from scratch will really help you from the data science side of things. This is why I've gone through these sorts of things. I would say that for many, many people, though, it isn't something that is super necessary. If I'm happy to share some resources on building LLMs from scratch that I found that I kind of enjoyed. But I would say for folks who aren't interested in doing that, like no worries. I don't think that that it's necessary. I think you learn a lot about the math. But we're kind of in a paradigm, right, where LLMs that we may use, such as OpenAI, take millions of dollars to build, hundreds of millions of dollars to build, maybe more than that. And so there's kind of a real difference between kind of what we'll be able to build or not, especially depending on what you mean from scratch. So there's some really great open source LLMs, things like Llama 2 and others that I've actually worked with and fine-tuned. But I still wouldn't say that I've built those from scratch. Mine are even more simple than that. Okay. That's the only question I see on YouTube. Let's keep going. So now let's talk about more of the code side of things, the practical side of things. How do we combine LangChain and WhyLabs? And maybe first, what are these things? And why do we care about them? So the first thing that I want to mention is that we're really focused on open source software here at WhyLabs. And you see logos here for both WhyLabs and LangChain. But a fun comment is or a fun challenge that I'd like you guys to do in the comments is if you can name all 5 of these logos for other open source machine learning initiatives. And why is open source important? So one, there's a lot of tools that have existed for machine learning that are open source that we're built on, right? So PyTorch, and in the past, many other tools and tools, underneath that, many like numerical tools and things like this. These have been here for a long time, and without these tools, machine learning wouldn't even exist as it is today. And then going further from that, tools that allow us to share new research and open source models and open source platforms for sharing data, and all of these sorts of things are so important and kind of integrated into our ecosystem. So it's really hard to extricate yourself from open source. And I also think that we really wouldn't want to, right? So being able to see the source and interact with it and contribute to it is a major benefit to us in understanding where our system may be failing and getting feedback about how to fix it and all of these sorts of things. And we're no different at WhyLabs. So let's keep going. So first we're going to talk about LangChain, and then we're going to talk about how that blends with what we have at WhyLabs and LangKit specifically. So LangChain, I'm very curious if folks have heard of this before. It's a very popular tool for composing different LLMs and different processes related to LLMs together. So I say that it's kind of reducing the engineering boilerplate with LangChain. So things that we can do might be seen here in the components for LangChain. And these things are changing all the time. So this is a fairly old example of it. But these are some basic components that we have. So we have different LLM models, things like OpenAI or things like open source LLMs that you might have access to. And we want to be able to communicate with the APIs to these different models. And it would take a lot of effort to write up some code, some boilerplate code often, to interact with these different systems, often in slightly different ways you need to format things, and so on and so forth. There's also lots of work that we have to do on the prompt side of things. So I think when we all first start working with LLMs, we're typing things directly in, but eventually when we start to think about how a system might work on top of an LLM, we have a lot of structure to how we would create a prompt. Maybe we want some template for that prompt. Maybe we think about how we're sending in metadata for that prompt. We may send it in different ways as a system prompt or as a user prompt sort of things. Lots of different kind of structure that needs to be added to prompts as we kind of move to production. I won't go through all of these, but just to say that there's other components that LangChain does really well. So agents to work with these things, a chain between these systems. So maybe you use an LLM and then you pass the results of that LLM into some other system that does some sort of guardrailing or something like this. We have the issue of memory. So many times when we're thinking about LLMs, we may be thinking in a chat context where you've asked a question and then you've gotten a response, and then you ask another question that presumes that there's some sort of history there. So keeping track of all of that history can be really complex as well. Something that we grapple with a lot as well over at WhyLabs. And so LangChain is really great for developing lots of best practices around all of these things and having a package that is, admittedly evolving a lot, but includes ways to combine these things together in a reasonable way. All right. So we are integrated into LangChain. So very popular package for doing this sort of stuff. And we'll see how to use it in a little bit. But this is just a call out that when you import LangChain, you are importing a WhyLabs callback handler, or you're able to import a WhyLabs callback handler to use it directly. You're downloading the tools that you need to be able to do that. And so how do we use it? We're going to see it both on this slide, but then we're going to see it in the demo in a little bit. But it's very, very simple. Really just lines 1 and 4 are involved with WhyLabs. The rest is kind of the very basics of what you need for LangChain. So once we've installed this, we just import the WhyLabs callback handler. And then when we use LangChain, which you'll see at the bottom, number 4, line 4 here, all we need to do is pass in a list of callbacks that we're using. So what's going to happen is that we use LangChain to do kind of our interaction with LLMs, maybe one, maybe multiple, maybe other systems around those LLMs. And then that information gets passed on to the WhyLabs open source tool, so in our case, LangKit and WhyLogs, to process from there. Okay, so now, what does that mean when we pass things on to WhyLogs? What does WhyLogs do? What does LangKit do? So WhyLogs is that tool. It was the little orange square that I talked about at the intro, where we profile the data. So we find a number of metrics, and we take the raw data, which is lots of private information, lots of stuff, and we reduce that down to statistics and metadata that are important for us to understand trends in our data, and specifically to kind of machine learning as well. So data profiling is this general concept of kind of analyzing a data set to find information and structure. You often collect things like descriptive statistics, types, patterns, keywords, search for data quality, that sort of thing. So LangKit is a tool specifically for text and LLMs on top of WhyLogs. And what we do there is we're actually curating a number of metrics that are important for text and LLMs. So the problem with just collecting some information from text is you may get some basic information about the length of strings or things like this, but that doesn't quite tell you, does this text look like a hallucination, or does this text seem more simple than the text that we've seen in the past? That sort of stuff, we've done a lot of work on curating a list of metrics that are important, especially for production systems, to understand trends and potential issues in your system related to security, related to data quality, related to governance, related to sentiment, and many more at this point. Okay, so you might ask, what's the point? Why are metrics so important? Why have a separate tool to do this? And I'm going to give an example with images, because one, I'd like to just belabor the point that generative AI can go beyond text, even though we're focusing on text today. But two, because I think it's more fun to see images than text on slides. So this on the left is an example of DC GAN. So this is a generative model that produced images from faces, from faces as well. And you can see the quality of it. It's a little painful to look at. And this, even in 2017, which is quite a while ago now for us here in 2024, is a different version of a GAN producing images of faces. Much better. But here's the question. If we were trying to detect differences in quality between the two, how would we do so algorithmically? How would you come up with metrics to do so? If folks have ideas for metrics, feel free to drop them in the chat. Just looking at these two, you certainly don't have to write down Python code in chat or anything like that, but just how would you write an algorithm to say, hey, this image looks more realistic than this image? I'll give you some time to come up with ideas. I'm going to share a few that I have. The number of eyes might be something that you think of. In some of these cases, there are less than two or more than two. But this already presents a problem. Like, how do we measure an eye? What do we know what an eye is? Things like the color gradient, so the sort of like clarity of gradient in colors. You might do similarity to some composite face, different things using models. So all of these things, there's a huge challenge in coming up with these metrics. And it doesn't make a lot of sense for all of us to kind of come up with these individually. And so a lot of our work at LangKit is starting this process of coming up with these metrics and aggregating these metrics from around for text, and then as well as metrics that we are gathering for other modalities like images. Okay, that's what I have for slides. And now I want to jump into the demo, which is perhaps the more fun part. So what I would want you to do is go to WhyLabs platform. Let me do that right here. Share my screen. Okay, so this is the WhyLabs platform. If you go to hub.ylabsapp.com, I will start on the start page here. I've cleared out. What you can see here, actually, let me just sign out and we will be on the same page. So you'll see a page like this. It may have something asked at the top. Mine doesn't since I've signed in, but go to log in. If you've been here before, welcome back. If you haven't, feel free to click sign up right here. Super fast process, as often is on the internet these days. So just your email address, you'll get an email and a link to click to confirm that's your email, and you'll be all signed up. And once you do that, you will be able to log in. So I've logged in with my Google account, so I'm just going to do that here. Oh, and maybe because I am signed in somewhere else. Okay. So this is, I've cleared this out for you guys so that I'm as close to fresh as possible. But once you get in, you'll probably have some more interesting tools to help you out. But what we're going to do is create a new model so that we can pass in some text. So I'm going to hit create resource here. I'm going to give a model name. So let's go ahead and call this LangKit demo. I'll just make one of them, keep it at daily, and you can change this to a large language model right here. And we'll add a model. Okay, so we'll get a couple of things here. We'll get a model ID. So be sure to note your model ID. Mine's 25 because I've made many models before. And there's a couple of other information points that we're going to want. So you're going to want to go and, well, first we'll take the model ID. Then we want our organization ID. So there's a couple of places that we can get that. One is up here at org, and then your org ID. Then you'll need to create an access token. So I have many access tokens, but if we click under settings, access tokens, you can give a name for your access token, type that in. You can give a date, expiration date if you want, but then you can create an access token by hitting that orange button. So once you've done that and you've stored those three things, then we are ready to get into the demo. I will show you how this works. Okay, we will reconnect to our demo here. And I will switch over. Okay, so now I'm switching over to the Colab notebook and just some instructions for Colab. So because this is a view only for you guys, what you'll need to do is go to File and then save a copy in Drive, and then you'll be able to run this notebook and edit this notebook as you want. Here's a link to get to your free WhyLabs account. And then the third thing is to have an OpenAI API key. So the OpenAI API key will allow you to use that particular LLM that we'll be using in our example. And here's some other useful links that may be helpful for you. So the first thing we'll do is just make sure that our system is running. So we have our hello world. And then the next thing we'll do is we'll want to install two things. So we're going to first install LangKit. So this is the WhyLabs open source project specifically for text and LLMs, which installs WhyLogs as well. But then we're going to install LangChain. And so as I mentioned before, LangChain actually has as a dependency LangKit in it, but we're going to use them separately to kind of understand what's working underneath the hood. So we're going to install both separately. I'm just going to close that and let this go. Oh, and it wants to stay open. That's okay. So this will take a little time. I'm going to check just chat really quickly. Thank you for sharing those links. All right, so we're downloaded here. I'm just going to close this again. Now, what I've done here is some setup for different organization IDs and all of the info that we just grabbed. So when I run this, I'm going to get a couple of pop-ups. And so the first thing I need to do is put in my organization ID. The second thing I need to do is put in my data set ID. So my case was model 25. Others will have different numbers. The third one is my API key. So this is the one that I would have made on WhyLabs. And then finally, my OpenAI key. So this is the one that you would get from OpenAI or the LLM that you're going to use. Here we're using OpenAI and pass that in. Okay, so once I've set these up, we're ready to rock and roll here. I just want to show you how to get started with LangKit. So it's super easy. All you need to do is actually import a particular module that you'd want, or kind of set of different modules that you want to use. So one example is the import LangKit from LangKit import LLM metrics. This is kind of a nice subset of different metrics that are important for LLMs. There's light metrics if you want a couple less, and then there's ways to get many more if we'd want as well. And I'm going to import YLogs because I'm going to directly use YLogs here for our example. So when I run this, this is going to take a little bit of time for the first time. That includes me since I'm on Colab here, because LangKit uses not only different methods to calculate metrics, but some of those methods include using machine learning models themselves. So you might use a machine learning model to detect something like sentiment or to detect something like reading score. And so there's a little bit of time to download those models for the first time. Okay, and then what happens after this is I want to initiate this into a schema. So a schema is just an object that we're going to use to hold all of the metrics about our data that we want to store and different settings and configuration settings for that. Okay, so let's get started. The first thing we're going to do is actually use some LangKit examples. We have some chats. So I'm going to call LangKit.ylog samples. We're going to load some chats, and then we're just going to see the first chat in our list. And then we're going to log it. So let's do all of those things at once. So we see that there's 50 examples. The first one has a prompt of hello and a response of world. Okay. And then we see for the first time what we're doing here is we're logging. Oh, no session found. Oh, okay. I guess what I could have done here is initiated. So let's do this code. We'll say y.init. So we're initiating a session here. Apologies, I think I deleted this a little bit earlier in my cleanup. And so this says we found WhyLabs information because we passed in all of this organization information, and we're all set to go. So now let's run this again. It should be a little faster. And we are going to see results from our log of our 50 records of data. And we've given a name of LangKit sample chats. So what do we see here? We see that we've aggregated those rows into some data profile. And we can click this link to, hopefully this thing will, yes, cool. Will load, and we see a number of metrics related to our text. Before we get to the metrics, let's go ahead and look at the text that we passed in. So what did we pass in? We saw let's see here. Let's look at chats. So in this first example, what I'm doing is I'm just passing in the raw text, so in a data frame of prompts and responses. And this goes back to the fact that LangKit and WhyLabs in general is very data-centric. So we're not forcing you to run the LLM through us or anything like that. This is something that LangChain does really well. But what we are asking for is just what's the raw text of the prompts, and then later the responses from your messages. So that's one way to interact with this. I'm gonna close this since that's lots of scrolling. I had code to do that right here. All right, well, close that as well. So what gets stored inside of this profile? We can look at a little bit of this. So we're going to take the profile. Oh, sorry, we'll show this a little better. We'll take the profile, and when we profiled, we saved this as an object called results. So now we can look at results, and we can look at a view of these results, because our results have these complex data structures that we don't really care about in this case. So we just want a view of them. And then we can actually look at them in a pandas format, which might be more familiar for us. So what do we see? We see different columns here. So the prompt itself, we see lots of different information. I wonder if this is just a tad too big to see. Yeah, some of these lines here. So we can see things like the cardinality. So this is like how many unique values do we have across your data? So the first thing that you might notice here is or that these are estimates, right? This is a statistics-based process. And so we have a lower bound and an upper bound for our estimate for cardinality, as well as lots of other things here. But one thing that's helpful to us, so if this was a production setting and we knew that we've sent 50 prompts, 50 examples to our data, we've already learned something about our data set, which is that there's at least 3 repeats, right? Or roughly 3 repeats, because there are 47 estimated unique examples, which means that we have 3 examples where maybe our system accidentally reran the same prompt or something like this. And this is worth knowing. Lots of other information about kind of the aggregate reading level of the data of the prompts that we've sent, the average character count, the number of difficult words, these sorts of things. So note that these are all the cardinality of these sorts of things, but we have different metrics here. So we might look at, for example, the mean. It's a little hard to see here, but so the mean character count is 81. And we can see the median character count is 59 characters, and so on and so forth. Our smallest character count for a prompt is a 6-character prompt, probably our hello. Okay, let's go forward. So that is that. And so now let's briefly kind of break this down a little bit and understand what's going on here. So first I'm going to actually go through using LangKit, OpenAI, and LangChain in kind of the longer way. And then we're going to wrap it up very quickly to see how to do it with the integration. So first, we want to understand how LangKit works and how you would LangChain works before we get to LangKit. So how do we use LangChain? LangChain, again, has many of these different components that are really helpful for us to make templates to call LLMs and different processes related to LLMs. So for example, I may want to start a chat with a couple of different types of prompts. So I'm going to create this template here that says the following. So I want a system message. So this, when you call at least OpenAI, you can pass in a message kind of to the system. So I'm telling the LLM, hey, you're a helpful assistant, and I want you to rewrite the user's text to sound more upbeat and happy. And then we have a human message prompt. So this would be a prompt that is from the user. And in this case, I'm just going to pass over whatever text they've provided. Okay. And then for using LangChain, For OpenAI, what I can do is LangChain.chat models import chat OpenAI and use this method to call OpenAI with this prompt. So first, let's just set up a variable pointing to this. Now let's create a new function that will take this and package it. So we'll take our prompt, we'll take our templates here, and we just want to call our LLM, so what we've just created, with our prompt that we pass in here. And then we're going to output it in a specific way, just that's helpful to me because LangChain can give the response in lots of different ways. We want to output the prompt as what we already had passed in, so we don't even need to pull it from LangChain. But we're going to dig into that response object and pass in the content of the response that we got from our LLM from LangChain. Okay, so now we have a new method. And so let's try this with an example. So I'm going to say something like, I don't like Mondays or Tuesdays for that matter. So this is already pretty negative, this is already pretty negative. So we'll see what the upbeat LLM should tell us as a response. Okay, and I might have a older way of doing this. All right, so what we see as a response is, I'm not particularly fond of Mondays or Tuesdays for that matter, but hey, the week is full of endless possibilities. So some upbeatness to that. Okay, so that's just one example of how we use LangChain, right? And so this idea of creating templates can be really helpful when we have applications, especially when we're giving some context to the LLM that we want to separate from inputs and prompts and so on. Now we can pass that info into LangKit. So we've already done some of this. We've already initiated and so on and so forth. We can just profile using the schema that we had before. So we've created one row because this is just one prompt that we've done. And we can see that profile there. Often what it's nice to do is actually give it a name. So giving this a name is especially important for like training data. So why don't we say something like positive example. I'm just going to give this one a name, and we'll look at that. Okay, probably was a little faster than the data. There we are. So we see not much of a histogram going on because we only have one data point, or I did this a little too quickly. But we've seen our data come up now. Okay. And we can, of course, look at the same view that we've seen before. Okay, we can obviously do this with multiple data points, but I want to move down to how to look a little further into our examples here. So let's see here. We'll have to, I think we've created a profile up here. So if I run this, we can see that the profile object is not just like a pandas data frame of data, but it's actually data structures that are underneath that contain kind of all of this important metrics and information that we might need about our data. So for example, this is one way to search for specifically the distribution max of a particular metric being the aggregate reading level of the response. And we can see the answer here being 28. So this tells us a little bit about the scale of the reading levels, which you can look into more detail in our docs. Okay, so now what I want to do is maybe pass straight down to how we might use this. So in our example here, what we could do is make another one of these. This time I'm going to use a telemetry agent. Oh, probably need to run this cell before. We're going to use a different kind of pattern to do this. So instead of just ylog directly and passing in the schema, what we can also do is create a writer. In this writer, we can give many settings about how this information will be passed from ylogs to and LangKit to the WhyLabs platform. So we can show this with another example, being a second model. I think for time, I'm just going to skip that. But I made a more grumpy version of the same system. And you can see that you'll have multiple models of information that can be kept separately and analyzed separately, because as you imagine, there's probably multiple streams of your application. And finally, we get to the code that we saw in the slides here. And this is of the official LangChain integration. So it's very simple, just a couple of lines of code in this case, to now call the callback handler for WhyLabs, create our LLM here with some settings, and we can do the same sort of thing. So this won't be our grumpy template. Just for this example, this will be just passing these back. But when we run this, we've called the LLM for all of these prompts. We now see the outputs of those down here in the response. And these are also passed on to WhyLabs. And so this is, a much faster way of doing this, but both are really viable. Both are fairly quick. Now I'm going to jump to the slides. I think that's pretty much it here. We'll skip through this, but just a reminder, so we kind of looked at 3 parts. So we looked at monitoring and actual production insights in the WhyLabs platform. And we actually didn't get a chance to look too deeply into those. But there's lots of really great insights that we can get here. If we look at, for example, demos, I might look at another one here. If we look at our demo organization, we'll see really great demos from LLM chatbots that we can see dashboards of, for example, security issues. Oh, I probably picked the wrong date. Let's go back here. LLM chatbot. We'll look at the profiles here. We'll look at a particular batch and time. And we can see for some historical data what's going on and kind of dig into issues. So I'll leave that more as an exercise to the user here. But there's lots of really interesting actionable insights that come out of this. And gives us kind of an end-to-end monitoring and observability approach of our data over time. All right. And then we have WhyLogs. So this is the tool that does that data profiling. And then LangKit, which has this LLM-specific tools and is integrated into LangChain. And then what we saw here before. Thank you. I'm going to check for questions and here's some instructions for swag and things as we kind of wait. All right. So I see one question, and that is, how is LangSmith different from LangChain, or sorry, to LangKit? So LangSmith is kind of a more recent addition to LangChain. There's too many Langs in the world today. And so LangKit is really meant, so our tool at WhyLabs is really meant for production settings. There's a lot of statistics and data science that goes into which metrics should be there, and what does this mean about observability of your system. So not only do we want kind of some standard metrics that we talk about in the research or talk about when we think about evaluating a machine learning model generally, we want to think about how those metrics are calibrated to production use cases, as well as how to do that in a way that is kind of private, so that we're not collecting the raw data, things like this. Works for distributed systems. So a whole different presentation to talk about why WhyLogs works for distributed systems very well. And so you can merge data from multiple systems together and still maintain the sanctity of those metrics, which is very rare and something that LangSmith doesn't do. And just really oriented toward production use cases and observability. Another question. So the prompt response pairs are sent to the WhyLabs API rather than having the metrics computed locally, correct? No, actually the opposite. So WhyLogs is the open source tool that locally does all of the calculation of the metrics. So that object is the only thing that gets passed. So only on your local machine does the prompt response pairs exist. And on that local machine, we calculate a bunch of metrics and send those metrics over. There is an option, if you'd like, to send some subset of those metrics, often the top 30 prompts and responses. So you can do that if you'd like, but that is not kind of the model. The model is to do all of that calculation locally and only send the metadata and distributional information. Great question. Thank you for allowing me to clarify that. Okay. I don't see any other questions here. I don't quite see LinkedIn questions in the same way. I will try to respond to those in text right after. Have a great day, everyone. And again, feel free to contact me via email, via lots of social media, just at my first name, Bernice. Here's the links to the slide and collab. And then if you would like some swag or objects, feel free to go to that link and join our community Slack. Okay, have a great day.